All right, let's prepare to get started. Okay, so before I going forward, is there any question up to this point? So far, so good. Okay, so we have done basically we have done this, right? We have done we build model and we test the accuracy of the model already. So right now we want to aggregate the data and use that data and use this model to predict the future, right? Okay. So first of all, we want to aggregate the data from like the last 3 months, right? We need to aggregate the data for these 3 months. So again, we will need to do a aggregation again, right? So, but the aggregation code is basically just copy from previous things. Just you need to filter the data that we only want to take the data that after December the 1st. Okay, and then the basic things, the rest are basically all the same. So I put this time I put the data in data frame B because we already use A, right? So this B data frame is a very important data frame because from now on, this is the data frame that we actually has the future prediction inside, right? So first of all, we need to before we predict the future, we need to do aggregate the data for the next 3 months, right? So to get the predictor, and then with this predictor in B, now we can see as we can see that we can do first of all we can predict the buying probability for every customer within B, right? So B had 2A531, right? As you can see that the number is a little different from A, right? Because this is the customer that buy from us in the first 3 months, right? Okay, and this is the number of customers that buy from us in the next 3 months. So the number of customers they will not be the same, right? Oh. Okay, so in order to predict the buying probability, it's very, very easy. You just co-predict, right? And you use B as the data frame, right? So you basically use the data that we aggregated within B to predict the buying probability for each of the customer within B, and it will put the buying probability in the variable capital buy, right? See, after I execute this code chunk, you will see that there will be a buy variable here, right? And this buy variable is actually the buying probability for each of this customer, each of these 2A531 customer. Okay, so this is the predicting for the future, right? So predicting probability is easier, but predicting when we predict the revenue, there's one complication that we need to deal with. Remember that when we build model, we transfer the monetary variables, right? Which is M and revenue, and also the buying amount variable. We take the log 10 transformation, right? So before we do the prediction, we need to mutate these two variables, right? we need to mutate these two variables as log with log transformation. Because when we are building model, we build we do the transformation before building the model, right? So right now we want to do the prediction. We need to, right, do the same transformation, right, for this predictor. Okay. And then after this transformation, we put the data in B2, and then we co-predict with B2. And see that, why do we do this exponential? This is the 10. We are using, this exponential function is basically the reverse function for log transformation, right? Okay, and the prediction variable is actually the original amount variable, right? Okay, so, and because we take a log transformation on the amount, right? So if you want to revert it back to the things, we need to do a 10 exponential, 10 base exponential, right? Okay, this is basically the complication here is that for predictors, you need to do the transformation before predicting, okay? And for the target variable, you need to do exponential transformation after the prediction. Let me say it again, right? It's a little bit complicated, right? For this monetary value variables, for this predictor, you have to do the transformation before predicting, right? Okay, because when we build a model, we are using the transferred variable, log transfer variable. So before prediction, you need to do that. But the target variable is also log transfer, okay? So after we do the prediction, we need to remember to do the exponential transformation, okay? To convert it back to the actual dollar value, okay? So these two things is basically we don't really need to remember a lot of things because the code is already here, right? So you can basically just follow the code. Okay. So the prediction after this transformation and prediction, you see that there's a variable called REV right here. So this is the buying amount. Right? So now for every one of these 28531 customer here in the B data frame, we already we have a predicted value for his buying probability and also a predicted value of his buying amount if he come to buy from us, right? Okay, so this is the buying probability and expected buying amount for each of these customers. All right. Okay. So B is a very important data frame here. Okay. So the thing that we after we have these two things, we can actually see the distribution of these two values. Right. This is the histogram for buying. This is buying probability, so you can see that it's from 0 to 1, right? Okay, so this is the distribution of the buying probability, and this is the distribution for buying amount. Okay, as you can see that for this buying amount, we need to do a log transformation to see a normal distribution, right? So this is just to take a look at the the distribution of these two prediction value. Okay, and then we can set B, right, because this is actually the result we want, right? Okay, so after we do this prediction, there's one more concept that I would like to introduce. This concept of CRV in modern marketing. The marketer can use this CRV to kind of evaluate the value of a customer to the company. Okay, and let me go to the slides first, because now in order to calculate CRV, you basically need to know like 3 things or 4 things. Okay, first of all is the predicted buying amount, and the second thing is the predicted buying probability, and the third thing is actually your basically your interest rate of your company. Okay, because when we are doing the CRV, we are using the discounted cash flow. The money, because we are calculating the profit contribution for each of the customer in the future for a period. Okay, and the money, the $1,000 today is value more than $1,000 in next year, right? Okay, so in the accounting, have you ever learned accounting yet? Okay, so if you learn accounting, you should know what it means by discounted cash flow, right? So this is kind of like a accounting concept, right? And T is the number of period that you want to use, right? And then M and R is actually our prediction value. Okay, and with that, you can basically calculate the worth, how much money a customer worth for your company, which is expected profit contribution to you, right? But so because we are using model to predict the behavior of every customer, right? So every customer has a unique CRV value, right? And her value change in times. Actually, if you calculate the customer at the end of first quarter and calculate the same and calculate the CRV for the same customer at the end of second quarter, the third quarter, you will see that the value change with time. Okay, so every customer has a different CRV value. It worth different money to you, and that value change with time, right? So in current marketing, there are many different ways to calculate CRV. I'm use the most simple one, right, to do the calculation, right? Okay, so let's take a look at. You really don't have to remember the this mathematical formula because here I already give you the formula is here, right? Okay, so basically you need a few things, right? The G is actually the operational margin, right? Because MI, the underscript I, it point to each individual. See, the CRV is for customer I CRV. We call it VI, right? So so the I is for each of the customer, and in data frame B, we already have the revenue, expected revenue contribution, right? and we also have the expected buying probability for each of the customer, right? Already, so the retending probability is actually repurchase probability, right? So the buying amount we already know, right? But we still need to do some assumption before we can calculate the CRV, right? For example, we need to know our this is revenue, right? If we want to transfer it into profit, we need to multiply it by our gross margin, right? So this is the margin. Usually, the retail business has a margin for about 30%. Okay, raw margin, I mean. And because right now each period is a month, right? So if we want to calculate the value that customer worth to us in 3 years, we need to like calculate 36, right? You need to know the period, and the period is actually the data that you it's the period that you aggregate the data, right? Okay, so right now we are doing a period is a month, right? Because we are predicting the amount of buying at March, right? We are predicting the buying probability in March, right? So our data period is actually a month. So if you want to have 3 years, you need to have this n equal to 36. And this is the monthly interest rate, okay? When you have a period as a month, then you need to put in the monthly interest rate, okay? If you have a period of quarter, you need to put in the quarterly interest rate, okay? And then basically this mathematical formulation can be transferred into R in this way, right? Okay, G is like gross margin, right? And this MI is basically just B revenue, right? For each of the customer, its expected buying amount for a month is here, right? And here is a summation, right? Because you want to predict the current period plus the next 36 period, right? Okay, so you need to do for example, here I use as apply, right? You can do 0 to n, and this is basically this expression basically reflect this mathematical expression, right? And then the raw sum is actually the S apply would do the iteration, and the raw sum is actually the summation, right? So well, it would take a while for you to get familiar with how to transfer mathematical formulation into R, but as long as I already give you these notebooks, right? So there is one thing that I want to emphasize. The most important things, the most important the thing that you can get from this class is this notebook, okay? So you don't really need to remember the splitting process is quite lengthy, right? The prediction of the application type of thing. You can reuse the code, right? Because for most of the company, for most of the B to C company, okay, they usually have the customer transaction records, right? And out of that customer transaction record, you can simply like reuse this notebook to do the analysis for them, right? To the predictive model and to do the prediction for them, okay? let me say it again. Although the process looks very lengthy and some of the code is looked a little bit complicated, okay, but you don't have to worry about that because you already have this notebook, right? Okay, so you only change the data, and then basically you can follow this notebook for every B2C company, as long as they have the customer transaction record, isn't it? Right? So don't throw it away. You need to keep this notebook, and you will do it. You will help you a lot when you do a business analysis, especially for marketing. Okay, so here we can calculate the CRV and put it in the this column name called CLV capital. And let's go back to RStudio. Now simply execute this code chunk, and then you see a CRV here, right? Okay, so now this B data frame is very, very important because it already it has buying probability and revenue, expected revenue contribution, and also the lifetime value for most of your customers, right? With that, I can actually, this is the histogram for CRV, right? And as you can see that the discounted value, the profit that each customer will give to you, the histogram, right? Most of the customer only worth about maybe 500 to I think it's about $300 to $1,000. Okay, this is profit. This is not revenue. Okay, this is the profit, and this is the discounted profit in the future for 3 years. Okay, so each of these customers will contribute about this amount of value to you. If you are using this CRV formula, as I told you, that if you learn marketing, right, you actually can see that in the textbook or actually in the paper, there are many different ways in calculating CRV. Okay? The formula that I'm using is a quite conservative one, so the value is kind of low. Okay, there are some development, but the adjustment would make the mathematical formulation very complicated, and I just want to here in this kind of like introductory course, I just want to give you the idea about what is customer lifetime value, because when you have the prediction for next month, you basically would like to project the prediction for the next month to a period of time. Right? Okay, so when you want to do that, you will need to do the discount cash flow process. Right? Just want to give you the concept. Okay, when you do the CRV, when you go to the company, the company may have a different way to calculate CRV. You just follow their way to calculate it, right? And as I told you, this is this way in calculating CRV is a quite conservative one, so the value is tend to be kind of like underestimated, right? Okay, so at the last of this notebook, we simply set this B data frame, because right now this B data frame have everything we want to know, right? Go back to, as we mentioned in the beginning of the class, right? Today we are using data to build model. We are using model to do prediction, okay? Okay, And then with the prediction of purchase probability and buying amount, we can project the lifetime value for each of our customers. Okay, and that already been done in the two notebook that we already that we just went through. Okay, and basically when you do your final, you don't really need to like do a different model and do a different prediction, right? I would suggest, because you don't really have too much time left, right? As I told you in the as we mentioned that after our next week we'll also have another class, and after that class you only have like 3 days, 2 days actually, to prepare your final video, right? So I kind of go pretty quick in this week, right? So so I can reserve some time to do assumption and simulation. Okay, so it will make our next week a little bit easier, right? And also you can start to prepare your final presentation earlier, right? And for today's in today's notebook 5 and notebook 6, I believe that you simply follow my step and calculate the CRV for each of the customer. Basically calculate the CRV, buying probability, and buying amount for the next month, right? This is the thing that and remember to save it into a data file, right? So you don't need to go through all of the data aggregation and modeling and prediction type of things, right? Everything is already kept in this B data frame, right? Okay. So when we do the assumption and simulation, we simply reuse this B data frame, right? Because that is all we need to know, right? For us to design and choose our instrument, for us to choose the customer that we want to apply the instrument, and for us to do the evaluation. Okay? Because every information is already within this B data frame. So this B data frame is very important. Got it? Okay? Okay. So today your working assignment is just to go through these two notebooks, and like I believe that you can you will have a B data frame, right? So you already have this prediction things. Okay. Okay. So and I want you to like when as a group assignment, I want you to like went through the code in the two notebook, and then upload the so you follow these two notebook and build model and to predict buying probability and amount, and then make prediction, right, for every customer, and then calculate CRV for every customer, and you can store that in the data frame, right? You can reuse the name B. I would suggest you reuse the name B, right? So the code is easier, and then you want to upload the HTML to here, right? Okay, got it. So you basically halfway done with your like final. Okay, so now in the we have 20 minutes left, right? So now we want to before further ado, I would like to give you a few just to give you a concept about what I expect you to do in the final project. Okay, so in the final project, we want you to do a marketing proposal. Okay, so basically, I want to use the result of analysis so far. I want you to make a marketing plan that I want you to design two instruments for two target customer segments. Okay? Not only one instrument, I want you to design two instruments. Okay? And then I want you to apply these two instruments to two target customer segments. Okay? And for each of instruments, you need to do assumption on its cost effectiveness, right? This is what I mean by MBA. I'll explain that later on. Okay. So this MBA is actually the instrument's cost effectiveness for a specific customer segment. Okay, I'll explain that later. Don't worry too much. So basically, in order to design and the instrument, you need to make some assumption, just as we have done, right, in the payoff matrix, right? So remember that you are using we want to make this assumption general and flexible, just like you can adjust the cost and effectiveness of the drugs, right? Next week I will give you some tool, right? So you can actually adjust the cost effectiveness of marketing instrument, right? With these parameters. I'll explain that later, okay? And then I want you to rationalize your assumption. Okay, again, I will explain that later, and evaluate the cost effectiveness of because you already know the buying probability and you already know the buying probability in B buy, right? And you already know the expected revenue for every customer, right? And this under this underscript is actually representing each of the individual customer, right? So for every customer, you know the probability P, you know the buying amount M, right? So, but the reason that we want to use a marketing instrument costs money, right? For example, if you want to send out a cash coupon, for simplicity, let's assume that we are sending out a cash coupon, right? It will cost some money, right? Okay? So why do you want to, with this cost, what do you want? What is your purpose for this cost? You want to raise the probability of purchasing, or you want to increase the amount of buying, right? Isn't it, right? Okay. So so the reason that we are using the marketing tool like cash coupon is because that we expect that after receiving this cash coupon, the buying probability or the buying amount for the customer will improve, right? Okay, and then we can follow this logic to you can see that this is the after we the pi prime is basically just pi plus delta p, right? And delta p is the amount of increment of buying probability after we apply instrument to this customer, right? Okay. So with this calculation, we can calculate the revenue increment and profit increment. And if you want to see the net cost effectiveness of applying this instrument to customer I, you basically can like use its profit increment and minus the cost, right? So and then if you apply to a group of customer, you just do a summation for this net value, right? So that is the basic logic that we would do the simulation, okay? The basic logic that we do the simulation is that by applying instrument to a customer, we expect that that customer's buying probability and buying amount would increase for a certain value, right? And with that, we can calculate the cost effectiveness of applying this instrument to that customer, right? But here is the problem that we do not actually know that for each of the customers how much. We do not know this delta P and delta M, right? This thing we do not know yet. And most importantly, usually, for example, again, we are sending out a cash coupon, and we expect that after receiving this cash coupon, the buying probability will increase by like some percentage, okay? But that percentage of increment would be a function of C, right? If I send a cash coupon of like just, let's take a look at this chart first, okay? Usually, if you, again, let's assume that this is the x-axis is the cost of the coupon, right? If you send a coupon of like just $5, and this y-axis is actually the expected increment of buying probability, okay? So this is delta P and this is X, okay? So, and see that when you do that, you can see that actually when you put only a very small number of costs, it usually do not have effect, right? Okay. For example, I send a cash coupon of $5. Basically, no one would like be interested in it, right? So the expected number of purchase probability almost do not increase. Okay. So up to a certain point, right? Up to a certain point, right? Maybe $10, $20, right? Okay. The curve start to the increment of X will start to take effect, right? Okay. So for example, here that up to about $10, I start to take effect, and then you will have an incremental effect. When X increase, the number of the increment of buying probability will also increase, right? Okay, and up to a certain point, right? The marginal effect would kind of like saturate it, right? This is in economic, we call it the diminished of marginal effect, right? So basically, all of the marketing instrument, or I should say most of the instrument, okay, would take an S-shaped cause-effect function, okay? which means that this is the cost. Okay, this is the face value of the cash coupon. Okay, and this is the percentage that that cash coupon in average would increase the buying probability, the amount of increment of buying probability. Okay, and that delta P, that P plus, is actually a function of X, right? So and you need to make an assumption, right, for each of these marketing instrument, right? We know that for every instrument it would take an S shape, but every instrument for every customer segment would have a different. Some S shape is actually higher, right? Okay, and some shape is actually lower, right? And some of this some of the S shape is like will move to the position. They are different, right? The M, B, and A parameter is actually the parameter of this S shape. The M parameter is basically the height, okay, which is the maximum value of this instrument, right? And some of the instrument will have a higher M, some will have a lower M, okay? And then the B is actually the midpoint of the rising curve, okay? The rising slope, okay? Which is the rising slope is actually the sensibility of this instrument against its cost, right? So some of the instruments have this rising slope, like on the left, and some of the instruments have the midpoint of this rising slope is specified by B, and the width of the rising slope is specified by A, right? Okay, so first of all, we know that generally all of the marketing instrument would take an S-shaped cause-effect function. Okay, and secondly, we know that we can use this MBA parameter to control the height, the position, and the width of the S curve. Okay, so if we next week I will tell you to write a program, right, that given MBA, you can basically simulate any type of marketing instrument. Okay, so this is the cost effectiveness assumption that we need to make before we can do this simulation, right? So this is the assumption, and we want to make our assumption general and flexible. By general, I mean that we only write one program for the S-curve. But in that program, we have 3 parameters is adjustable. Okay? So by adjusting the 3 parameters, you basically can simulate any instrument that you can use, right? So let me show you the idea, okay? Just like the simulator I give you when we do the diabetic medication case. Again, I will give you let me put it See, here I actually simulate two different. This is the S curve for the pink instrument and also the blue instrument. Okay, and as I told you, the M is the high, right? Take a look at the pink curve. Okay, if I raise, as you can see that it's it will be higher, right? And if I put the B higher, it will move to the right, right? If I put the B lower, it will actually move to the left, okay? And the A, if I make it wider, you'll see a wider curve, right? If I put it shorter, you'll see a narrower rising slope, right? So what I mean by general and flexible is that I only write the program once, okay? But I can adjust the MBA knowing that every marking instrument will follow this S curve, okay? So as long as I can adjust their height, their position, and their width, okay? I basically can use this same simulation program to simulate an instrument, any instrument that has the S-shape cause effect function, isn't it, right? And that's what I am going to cover in next week. Okay? Okay? So after next week, basically we would tell you how to make the assumption by setting the high, by setting the parameter of the cost-effective function of marketing instrument, right? And that is basically that is this thing. Okay? So besides the prediction, you need to do assumption on marketing instrument, right? And you make the assumption by setting a different MBA per instrument per market segment, okay? And you need to rationalize your assumption, right? As I show here, that we have two instruments here, right? And this instrument is like actually take effect like in the low cost, and this instrument take effect in the higher cost, right? But this instrument actually has basically a higher potential to raise the probability higher, right, than this one. Okay, so with that we can simulate the expected return, right? We'll know that what is the optimum cost for each of the instrument, right? And we also know that the expected return when we do these two instruments, right? And this is number of customers selected. Okay. So next week I would go through. I will use a notebook and also some simulated app to run you through this assumption. By assumption, I mean adjusting this MBA to reflect different type of marketing instrument. Okay, and by simulation, I mean that with this assumption and the prediction, we can actually expect the result. Okay, we can know the what is the base value for the cash coupon, right? Okay, then we can know with that setting how many customer we would apply, and we actually would know that when we apply the instrument of that parameter to a specific customer group, what is the expected return that we will get, right? So this is basically what I want you to do, right? As I told you that after next week's class, you only have 2 days left for your final, right? Because we are pulling forward the final to the Sunday, right? Okay, next Sunday should be yeah, this Sunday, next Sunday. Okay, so I'll basically give you the simulation tool, right? So I want you to like use the tool. I don't want you to spend too much time in doing programming. Okay, I want you to use the tool to make the marketing proposal, right? And in that proposal, you need to do assumption by setting the MBA or marketing instrument. And you need to rationalize why you set the MBA in that way, right? Okay, and then you need to make your business proposal, and in that proposal you need to specify specify your instrument, your target segment, and why the instrument applied to that target instrument will have that MBA, right? You need to explain that. And so if you want to, as I show here, that after simulation you will know the budget requirement and also the expected payoff, right? So I want you to like report the performance improvement, right? In terms of revenue, in terms of profit, right? Okay. In terms of raw margin, perhaps. Okay. So that is basically the plan that we want to do. Okay. Next week, I will show you how to do a generalized and flexible assumption, so that with the simulation, we can use it to design the instrument, choose the instrument, and choose the customer segment, and also make the expected return. Okay? And then hopefully I can, this tool that I'm give, the simulation tool that I give you is good enough for you to do the final presentation. Okay? You got it? Okay? So because your time is squeezed very tightly, I think this is the best way that we can do, right? Okay, I go through the assumption, and this week we already done with this part, right? And next week we'll go through this part, okay? And after next week you will have some simulator to help you do the marketing proposal for your final presentation. Okay, that's all I want to go this week. And before I stop, I remind you again, we need to do the what to call it? We need to do the evaluation questionnaire, right? Okay. Please take some time to do this questionnaire. Like, it should take you like 5 minutes to do that. Okay? If you haven't do it. Okay, that's all for today. And if no question, let's start preparing for your final. Okay? Start preparing for your final.